Okay, number 3, we're asked to verify that big F is a general antiderivative of little f. What's that mean? That means we have to show that big F prime of x is equal to little f of x. So, let's look at f of x. It's x times e to the x minus e to the x plus a constant c. So how do you take f prime of x? Well, I'm taking the derivative of x e to the x minus the derivative of e to the x plus the derivative of a constant. This is a product of two functions of x, so I need the product rule. I take the derivative of the first one times the second plus the first times the derivative of the second. So these first two terms are your product rule from Calc 1. Now this guy, the derivative of e to the x, well, that's e to the x. And the derivative of a constant is 0. And so now we simplify. The derivative of x is 1, so 1 times e to the x is e to the x, plus x times the derivative of e to the x is e to the x, minus e to the x. And so when the dust settles, these e to the x's cancel. I'm left with x e to the x. And sure enough, x e to the x is little f of x. So, to verify one function is an antiderivative of the other, you take the derivative and show the derivative equals what it should. And that's it for problem 3. Okay, problem number 4. We're asked to find this indefinite integral. So we're asked to find an antiderivative here. One thing we can do is break this antiderivative up and find the antiderivative of each piece. This is the antiderivative of 1 dx minus the antiderivative of 2x dx minus the antiderivative of 10 over x squared dx plus the antiderivative of cube root of x dx. The antiderivative of 1 dx is x plus a constant, which we'll put at the very end, minus the antiderivative of 2x. We've seen this a couple times today already. That's x squared. Now for these two, we're going to have to rewrite some things. 10 divided by x squared I can rewrite as 10x to the minus 2 dx. And the cube root of x I can rewrite as x to the 1/3 dx. X minus x squared. Now, the 10 is a constant, which means it's a constant multiple. It'll be a constant multiple of our answer. Minus 10. You add 1 to the exponent. So adding 1 to negative 2 is negative 1. And then divide by that new exponent. Plus x to the. Adding 1 to the exponent is the same as adding 3/3. That gives you 4/3 divided by 4/3. And then there's the arbitrary constant tacked on to the end. And now we simplify. X minus x squared plus 10x to the minus first plus 3/4 x to the 4/3 plus c. If you want to, you can rewrite this as 10 divided by x and write this as x, the cube root of x to the 4th, but this is a perfectly acceptable answer. Okay, our last problem on Checkpoint Quiz 1. Write and evaluate a definite integral to find the area shaded below. So the area is between the curve y equals 4 minus x squared and the x-axis. Since 4 minus x squared is above the x-axis for that entire stretch between minus 2 and 2, I can write that area as the definite integral 4 minus x squared dx from negative 2 to 2. We'll evaluate this using the fundamental theorem of calculus. Step 1, we take an antiderivative of the integrand. An antiderivative of 4 is 4x. An antiderivative of x squared is x cubed over 3. And then we evaluate this from x equals negative 2 to x equals 2. Substitute in the top limit I get 4 times 2 minus 2 cubed over 3 minus, substitute the lower limit, 4 times negative 2 minus negative 2 cubed over 3. Note the importance of the parentheses here. I get 4 times 2, which is 8, minus 8 thirds, minus a negative 8 plus 8 thirds. So I get 8 minus a negative 8, that's 16, plus negative 8 thirds minus 8 thirds minus 16 thirds. 16 is 48 thirds. 48 minus 16 is 32. Our final answer then is 32 thirds. And that'll do it for checkpoint quiz 1.